Hello, good evening and good morning to everyone. My name is Shirley Meng. 我的中文名字叫孟颖. I'm a professor at the Preschool School of Molecular Engineering of University of Chicago, and I also serve as the chief scientist for Argonne's Collaborative Center for Energy Storage Science at Argonne National Lab. Welcome to the panel discussion today, titled The Transformative Potential of Clean Energy Technologies, which is a part of the University of Chicago and the Peking University Joint Forum on addressing the climate and the energy challenge. We are very excited to have all of you here today with us. Before we begin, just a few housekeeping items. Today's event will be conducted in English and Chinese. So to listen to today's program in Mandarin, please click on the interpretation icon at the bottom of your screen and select Chinese as the channel. If you would like to listen to the program in English, then you click on the interpretation icon at the bottom of screen and select English. And during the Q&A session, please feel free to submit your question either in English or in Chinese throughout the event. Climate and energy challenge is a global challenge that requires cooperation among all the countries. The United States and China are the two largest economies in the world. So for humanity to tackle the energy and the climate crisis, we have to accelerate our efforts by sharing our wisdoms and knowledge. The clock is ticking. We have to remember that we are all citizens of the planet of Earth, and it is our duty to protect the planet and make it a better place for our children and their children. With such sentiment, I'm grateful that I have the opportunity to host today's joint forum to discuss about the transformative potential of clean energy technologies. We will hear from world-leading experts from both US and China about the blueprint for energy storage, as well as hydrogen and other important topics. Before I ask each of our speakers to introduce themselves, I want to start today's event by launching a poll. I will encourage all of you to respond to the questions throughout the event because each of the speakers will actually share their important insights on these answers. And I think the polling is right now on the screen. And at the end of the webinar, we're going to release the answer. And of course, hopefully this session bring you back a lot of important knowledge and the important data. So please answer the question on the post right now. We will give 1 minute before we start the actual talks. Okay. Let me now introduce the first speaker of tonight is Mr. Zhao Jishi, Professor Zhao Jishi, who will give us his view on the clean energy technology. So please, Jishi, the microphone is yours. Yeah.
Oh, OK. 大家好，我叫赵基师。为了更好的表达观点呢，我用中文发言啊。然后很高兴参加今天的交流。我主要聚焦的是氢能技术的研发和应用啊，以及它在就是气候变化中的这样的一个作用啊。谢谢大家。我这边没有 PPT， 然后我想跟大家分享几个问题吧，啊，几个方面的观点吧。第一个呢，我觉得就是现在随着可再生能源装机容量的这种提升，然后储能的市场规模呢是要快速的去增长。那么因为电网的这种就是对可再生能源这种波动性的这种容纳吧或者消纳的这种作用，它是比较就是目前来看是有限的啊。那么根据我们国家的就是根据中国吧，就是东南沿海5个省的这样一个 电力未来的发展的未来几年电力的一个需求，我们需要大量的这样的一个就是特高压的这种电力输送能力。那么这个一方面呢是这个建设的成本比较高，另一方面呢就是通过建设这个特高压的这种输送的话，对我们生态环境的这种影响或者评估吧，也是一个潜在的一个问题。那所以说储能的话，未来我们是通过这种，当然我看今天也有李红老师，然后李教授，然后他是我们做电化储能领域的这个大专家啊。那我们的话就是储能的方向的话，目前有像抽水蓄能，然后像压缩空气，然后像这个电化储能，以及我们的这个现在可能在未来具有一定前景的这样一个电转气的这样一个储能啊，也就是说气网和电网的这种融合。那么我们经过几年的研究，我们大概从17年吧，然后开始关注这个就是可再生能源储能的这个方向。我们目前看呢，就是因为我本身呢，我自己之前是这个天然气管道有过在天然气管道公司工作的经历，所以对这个就是我们有一个初步的一个结论吧，就是未来的话储能的话，有可能通过电解水制氢。然后氢到这个天然气管网里面，然后去掺氢也好，还是通过这种纯氢管道的这个输送也好，然后解决我们这种大规模长周期的这样一个储能的这种需求。所以我们认为呢，就是在未来的话，比如到2030年，然后甚至更长远的这样的一个时期，那么氢网，也就是那个电网和这个我们的这个地下的天然气的这个管网，它的一个融合，可能会成为我们储能的一个重要的一个方向啊，这是第一个问题。那么第二个呢就是目前的话，那么氢储能的话面临几个方面的这种压力吧，一个呢是说我们现在电解水制氢的话技术的话，大概有4种，有这个减槽的 ALK 的，然后还有这个 PEM 的，还有叫 PEM 的，然后还有个 AEM 的，还有一个 SOEC 的，那么4种技术路线。那么当然还有一些其他的，比如说像光催化呀这样的一些技术，但是它不属于电解水的那个范畴。那么这4种技术里面呢，目前已经在商业化应用的，就是这个我们的减槽技术 ALK 的。那么在欧美呢，就是在发达国家呢，这个 PEM 的这个技术路线发展也比较成熟。AEM 和 SOEC 的话，目前还处于一个就是实验室向这个示范应用这样去转化的这样一个过程。所以说技术的这个成熟度是一个问题，是面临的未来的一个挑战吧啊。所以说下一步的话就是说要去推动这种气网融合，然后要去加快这种技术的这种创新啊，这是一方面。那么第二方面呢，就是其实跟第一方面有很强的相关性。因为这个技术不成熟，所以说整个的这个市场规模的话，目前还比较小，包括这种 ALK 的这种技术啊，还有 PEM 的这种技术。那么在未来的话呢，就是要那么因为市场规模比较小，然后所以它的这个成本的话，目前是比较高的啊，很难以去承受这样一个就是目前市场的话，就是市场化的这种行为去难以承受到这种成本。那么我们判断呢，就是这个成本的降低可能还需要这个5到10年的这样一个时间吧啊，然后去推动这个降低这个成本啊。那么第三个呢，实际上我觉得是就是这个经济性的比较的话，实际上也面临其他各种技术，刚才说到的电化储能技术啊，其他各种储能技术的一个竞争吧啊。所以这个第三个呢，就是需要通过这种政策的这种导向，比如说像我们的这种碳交易啊，或者是碳税啊等等这样的一些方式啊。就是政策的这种导向，然后要去推动我们的这种规模化的这种应用啊，就是有更合理的这种政策，然后促进这种加快这种技术迭代和这种成本的降低啊。那目前的话就是可能主要面临这3个方面的这个问题啊。我先阐述2个观点吧，就是这两个方面的一个观点吧。一个是气网融合有可能那个气电融合有可能会成为这个储能未来的一个主流的方向。那么第二个呢是这个电化储能，就那个电解水制氢这个储能，面临3个方面的挑战吧，一个是技术，一个是成本，还有一个是政策和标准啊。谢谢。
So can I ask you a very quick question regarding your view of the using the hydrogen generated from the water. You refer that there are three big challenges. The technology, can you technology, cost, and also the policy. I guess could you elaborate a little bit on the technology part for the water splitting to hydrogen?
技术呢，就是技术的话，因为电解水制氢这个它其实也是一个比较复杂的一个体系啊。然后刚才介绍到就是有4个，目前来看的话有4个技术方向啊，技术路线。那么在全球范围内来看呢，就是这个碱性槽，就是 ALK 这个技术呢是发展比较成熟的。那么下一步的就是因为我们刚才说到这个未来的这个可再生能源储能呢，它是一个规模很大的一个储能的需求，而且也是需要一个长周期的一个储能需求。那么规模比较大呢，就对这个就是电转气的这个就是容量吧，就是我们说容量产生了一个比较高的要求。所以现在我们像 ALK 这个技术方向，目前是像比如说我们单槽或者叫单体的装置有几百方，然后现在像几千方的这样的一个方式去发展。那么目前国内的话，就是像中国国内，目前我们已经在投产应用的，就是实现工业化应用的，已经有1000方每小时的这样的一个ALK 技术装备在应用。然后呢，现在正在这个示范推出来的，就是那个已经推出来这种工业化产品，准备推向市场去示范应用的，有2000方这样的一个大的装置。那么随着这种储能的需求的规模提升呢，这个单堆的这个装置啊，可能也要进一步提升，因为单台装置的这个制氢能力或者叫容量的提升，也是降成本的一个本身也是降成本的一个手段啊。这是那个碱性槽的，就是 ALK 的这个技术。那么 PEM 这个技术呢，就是 PM 这个技术呢，就面临更多的挑战。首先呢，这个PM 技术呢，它需要这样一个贵金属催化剂，也就是这个金属铱作为它的一个催化剂。那么这个铱的话，这个整个的全球的这个储量就比较有限。那么我们在后面去运用的时候，可能大规模去运用，如果说不改进我们的催化剂的体系的话，那就有可能会面临这样的一个资源上面的一个限制啊。那所以说这个催化剂的这种就是低贵金属的催化剂，或者是非贵金属的这个催化剂的开发，就是我们这个 PEM 技术的路线的一个很重要的一个研究方向。那么第二个呢，是我们的这个PEM 这个技术，就是 PM 这个技术，我们要做大的话呢，实际上还有跟材料也相关，就是我们的这个质子交换膜的这个材料。那么目前来看的话，就是说，因为要做成这个比较大的这种单槽的话，需要我们这个材料有很好的这个就是连续生产的这个能力。那么目前的话，像国内的这个技术的话，实际上是相对来说比较薄弱的。那么国际上的话，像欧美啊，然后还有这个日本，在那个质子交换膜的这方面的这个生产技术是领先的啊。那么当然领先呢，就是整个像全球的这个供应能力的话，就是大量的这种供应能力其实还是有欠缺的啊。所以这个质子交换膜材料这块也是一个很重要的一个重点。那么还有一个呢，就是AEM， 也就是我们说阴离子膜，然后碱性电解水技术。那么这个技术目前主要卡在是2个方面，一个也是这个膜的问题，阴离子膜。要做出阴离子膜呢，因为它在这个强碱性的这个条件下，然后呢，它有可能就是容易产生这个就是那个容易降解。那么容易降解之后呢，它的这个电化性能就会衰减。所以开发这个长寿命的这样一个阴离子膜，就是未来要解决的一个重要的一个问题。那么同时呢，同样的跟这个 PEM 路线一样的，还有一个这个催化剂的这个催化剂体系的这个研究，这个也是要去进一步做那个研究的。那么 SOEC 呢，实际上是跟这个SOFC 是同步的。那么目前面临的很多的问题，都是因为在高温体系下工作。那么目前面临的很多问题都是在高温条件下对这个材料或者是对这些部件，它提出了很高的这种性能的要求。那么这个呢，就是从材料和零部件的这个在高温的耐受性啊这些可能都是未来研究的这样一个重点。再就是呢，这个还有一点呢，就是说我们现在做出的就是国际上做出的这个 SOEC， 我们的单台的这个装置呢实际上是比较小的。 那这个单台装置的这个大型化，可能也是未来主要解决的一个技术研究方向啊。谢谢主持人。
Thank you, Professor Zhao. That's a really insightful comments. I think we should move to the next speaker. Professor Ming will give a perspective from the US side. So thank you, Professor Zhao. Next, it's my pleasure to introduce Professor Nguyen Ming from University of California, San Diego. Ming, the microphone is yours, and please go ahead.
Thank you, Shirley. My great pleasure to participate in this panel. And good morning, good afternoon, good evening, everyone, depending on where you are. My name is Nguyen Minh. I'm with the at the Center for Energy Research at the University of California, San Diego, or UCSD. Before joining UCSD, I worked in industry. My last position, I was chief scientist at General Electric. My R&D areas of interest is fuel cell technology for power generation and electrolysis technology for hydrogen production. So today I would like to make some remarks on hydrogen in the US. Well, according to the US Department of Energy, or DOE, world energy consumption will increase about 28% from now to 2040, with fossil being the major source for energy sources worldwide. As the uses of fossil increase, energy-related CO2 emission will increase accordingly, estimated to be about 0.6% per year. So in order to meet this energy growth while limiting CO2 emission, possible strategies and approaches are the use of clean fuels, development of clean and more efficient energy system, and expansion of use of renewable energy. In this respect, hydrogen is an enabling technology because hydrogen is a clean fuel. It can be used in fuel cell efficiently to produce clean electricity, and it can be produced cleanly when it coupled with renewable energy. In the US, significant activity on hydrogen development, hydrogen technology have been going on in the last 20 years or so, and recently have been accelerated a lot. The US Department of Energy, or DOE, leads the development of the hydrogen technology, providing support various R&D activity in industry, university, national labs on a broad spectrum of area related to the technology, from production, storage, to delivery and usage. In the US, we have a long-term clean hydrogen strategy and roadmap, and that's been developed by DOE, and with the goal to get net zero emission by 2050. DOE also has established a number of consortia that include all the stakeholders and coordinate the R&D activity in specific area. For example, we have a consortium called H2New for hydrogen for new next generation of electrolyzer of water, or ElectroCat for development of catalysts for fuel cells and electrolyzer. DOE have recently, or last year actually, DOE have launched hydrogen shot with the goal of 111 for $1 for 1 kilogram of hydrogen in a decade or in 10 years. And recently, DOE have launched a new important initiative to accelerate the development of hydrogen, including $8 billion regional clean hydrogen hubs, $1 billion for clean hydrogen electrolysis, and about 500 million for clean hydrogen manufacturing. So that's all my remark on the hydrogen in the US, and thank you very much for your attention.
Thank you, Min. We will circle back later with more questions. I think now, after we hear quite a bit of update on the hydrogen, let's move on to hearing update from Professor Hong Li about energy storage, electrochemical energy storage particularly. Professor Hong, the microphone is yours.
Okay, thanks, Shirley. I'm Hong Li from Institute of Physics, Chinese Academy of Science. I have studied the lithium-ion battery about 27 years. So I'm a permanent staff in Institute of Physics. So I'm also in charge of the make deploy for national energy, and also the national key program for energy storage and smart grid program. So it's my pleasure to join this panel discussion and see my personal viewpoint about the climate and the energy challenge. This is a very important topic. So as introduced by Professor Zhao just now, so we care much about renewable energy. And actually China issues action for achieving carbon dioxide emission peaking before 2030 and neutral before 2060. So in the year of the 2025, we have a target that 20% energy from the non-fossil fuels. And to achieve this target for short-term and the long-term, it's need a green and the low-carbon energy transition action. So one of the main strategies for achieving our target is to develop a new energy car. So especially electric car powered by batteries and fuel cells. So we have already started the national key program about 20 years. So step by step, electric vehicle become very important. And at this year, it is expected that 5 million electric vehicles will be produced in and appeared in market. I noticed they are poor today. And also 100 million will be realized before 2030. So this is really a big transition. How to reach the target and how to keep the same performance as combustion engine car. So we try to develop the advanced battery technology, such as in the last 2 years and these years, the national key program has already started, so-called hybrid solid liquid electrolyte battery with an energy density of 400 watt-hour per kilogram and 600 watt-hour per kilogram or solid-state batteries for futures possibility. And also we try to develop the many supporting technologies such as life prediction and the safety prediction and warning and smart sensor and artificial intelligence technology to predict the state of health of the battery and also to extend the life of the batteries. And another important actions, as mentioned by Professor Zhao, is to we have to try hard to develop a renewable energy, especially solar panel cell, and also the wind energy. So in order to develop this, we need to large-scale energy storage technology. This part includes 3 parts. One is the short period energy storage, such as the flywheel, supercapacitor, high-power lithium battery, and high-power sodium-ion battery in future. And in order to satisfy the frequency adjustment and the electricity quality control, such kind of application, and then we will develop the so-called mid-term energy storage technology. There are many available physical and electrochemical energy storage technology. Currently, the main technology is the lithium-ion battery. In the world, it is 90% ratio. In China, also 91% in last year. So, because of the safety concern in the main market is lithium-ion phosphate-based lithium batteries. So in future, we want to develop the other technologies such as sodium-ion batteries without lithium source concern, and also the liquid metal batteries, redox flow batteries, and water-based batteries, and also sulfur-based energy storage type batteries, and also thermal storage, cooling storage, and also some compressed air batteries for the middle period, means within 4 hours. But another big challenge is the long-term energy storage challenge. So currently we use the pump, the water station, but it's limited by the nature source. So we are trying to develop the advanced compressed air energy storage technology, and also different type of redox flow batteries, and also the thermal energy storage and cooling energy storage, and the gravity energy storage, and also some new long-term energy storage, especially hydrogen. Hydrogen has been considered as not only the fuel for fuel cell electric vehicles, but also as a long-term energy storage medium for the energy storage. This is very important, and because of the difficulty for transportation and storage of hydrogen, we also developed as alternative methods, such as the reaction between carbon dioxide with hydrogen to form the methanol and other fuels, which is easily to be transported. This is an alternative path. So together, synergetic development of the electrified transportation and renewable energy revolution is very important. For that purpose, advanced battery and hydrogen energy could both support the transportation and energy field. And also, in order to realize this kind of large-scale development, sustainable development and clean development is very important and required in all chains, in all the production chains, and to realize and to reach a circular economy is very important in view of the whole life of the energy storage medium. And of course, it's very important not only encouraged by the policy, but also by the market. So we need to consider very important economic efficiency for all kinds of energy storage technology, for all kinds of applications. So for that, for me, I think the sodium solid battery, sodium-ion battery are very promising technology. In addition, for the long-term development of hydrogen energy storage. Okay, that's my the comment and understanding for this topic.
Thank you, Professor Lee. This is really appreciated the insight you share. Especially, I work on battery as well, so I really share some of your insights. 100% agree. I think next we will move to Professor Yang Lei from Peking University. Professor Yang, the microphone is yours.
Okay, thank you, Shirley. And here I want to talk about the electric vehicle and the energy system. According to the Chinese top EV think tank, the EV100's outlook, there will be more than 80 million new energy vehicles in China up to 2030. Now we have only 10 million around EVs, and it's good news, but also very challenging one. If the grid keep doing business as usual, it's impossible to support so large amount of number of EVs. If you consider to charge all the 80 million EVs at the same time, it will need all the current generation capacity, and it will collapse. The smart charging will solve part of the problem. The EV could be charged during low load time, such as night, and to avoid more burden to the grid during peak time. In fact, the EVs with the battery are natural partner of renewables. The solar and wind are variable, and the battery in the car would be treated as a mobile storage. With the support of digitalization and other technologies, we call the V2G, the vehicle to grid. The EVs will enable huge mobile energy storage capacity. As we mentioned, even half of the 80 million EVs work with the V2G model. It means almost 10% of the whole daily electricity consumption in China, which will play a big role in the peak support. But I must say, it's not a naturally happened thing. The framework of the grid and the policy must be changed greatly to have a new framework, in fact. A well-functioning market with support price is essential to enable the new business model. You can imagine if the company couldn't earn money, then they wouldn't do this business. But I see the big potential there, and I do believe with the carbon neutrality progress, the V2G and the related business model will be very promising in the future. Thank you. I stop here.
Thank you, Professor Yang. I think we should probably get all the brains now. Let me invite all the panelists to turn on your camera, and I will ask a few questions. And before we invite the audience to ask questions. So I think, Professor Yang, you mentioned a really good point about a new kind of business model, because the current way of running the electric vehicle, which is only one way from the grid to the car, but now we have to think about how to use the vehicle as part of the grid. So I want to maybe link your comments with Professor Hong Li's comments about all the battery effort. What are the major technical challenges to make a vehicle to grid a reality? Because I have heard the concept for over a decade, but the implementation was very slow. Could you comment on are there technical barriers or are they mostly policy barriers?
It's for Hongli, right?
Yes. So you don't think it's a policy barrier. Professor Li, do you have any comments on the technical barriers for V2G?
Yeah, in order to realize V2G commercially, so we have to try to decrease the cost for several technology. Firstly, you need the automatic driving, 100% automatic driving, and automatic parking systems. You need to also start. And the third one is automatic charging systems. You need to automatically remove the car to the special position, to the charging station, and automatic charging, and then after charging, automatic parking. Only with this kind of technology is possible. Otherwise, such as current case, in the evening you would not want to change your car for the V2G. So for the fast charging station, 1 hour is normally enough, even 20 minutes. If we can form this kind of systems completely, then it's possible for the V2G commercialization. And for that purpose, you see the cost, several technology is needed. We have to accurately calculate the cost for each step and then separate the profit for the customer, for the driver, and also the grid and all of them. So I think although we have tried to develop V2G in the central government since 2020, but we still expect for commercialization could be the 2030. All the technology is available and convenient and economic acceptable. Otherwise, it's just a concept right now. So there are a lot of demonstration in this small area, but it still is difficult for the large-scale development because of those.
Yeah. Thank you, Professor Li. I wanted to invite all the audience to type your question in the Q&A. Don't forget, we will have a session that we invite all the general audience questions. Let me move on to my next questions, maybe a little bit difficult. I would like to direct my next question to Professor Zhao and Professor Ming about hydrogen. So as we all remember, back in 2000, we had a very big wave of enabling hydrogen economy in the United States. I think the world also followed right after that. Could you make some comments about what are different today compared to 20 plus years ago? Why we believe the timing now is the best and we can actually enable the hydrogen economy?
I just asked a question. 20 years ago, sure, you have a good question that why 20 years ago start and then things all like died down a little bit and now it's what the difference now? I think the difference now, in the last 20 years, there's significant progress in terms of material improvement, in terms of design, in terms of operation. So there's some significant improvement over the year in terms for the electrolysis technology. But still further work in it doing. I think DOE now recognize that there are a lot of things that need to accelerate. So they like to put more effort into, for example, into production. Before we more focus on the fuel cell car rather than hydrogen production. In terms of storage, you need to develop way that to store the hydrogen and delivery. The how you deliver hydrogen to the consumers and that thing. Although I know that the goal is very aggressive, but you know, with a lot of effort and collaboration, I believe that that could be achievable.
I think Professor Zhao, do you have anything to add? I was not familiar with 20 years ago what the effort China has put in for pursuing hydrogen, but could you add some of your perspective from China, why the government believe it's the timing is right now for hydrogen?
首先我特别同意我们芝加哥大学闵教授的这个观点，就是说今天和20年前的一个最大的不同是我们材料技术的进步。材料技术的进步呢，就推动了我们的整个的这个装备，然后它的这个就是您比如说刚才我们提到的这个大型化的问题，实际上这个跟材料技术是息息相关的啊。那么这里面我想补充一点呢，就是说其实跟这个整个的这个社会发展阶段也有很大的这样的一个关系。因为在20年前，我们全球对这个气候应对气候变化，还有我们低碳发展的这个迫切性，跟我们现在比较的话，还是没有那么强，应该说啊，那么现在呢，就是随着这个我们的这个巴黎协定开始了，然后我们现在的这个全球要去低碳发展的这样一个共识，已经形成一个广泛的一个共识。然后跟我们的技术进步的这种结合点呢，就在现在是有了一个比较好的一个就是更好的凸显出来了，这是宏观层面的一个情况哈那么您刚才问了一个说为什么中国觉得现在是发展氢能的一个好的一个时机，还是一方面是技术的一个进步，就是说成本降下来了，然后呢我们社会然后呢就是社会的刚才那个李教授也提到我们3060的这样一个目标啊。然后呢，有这样的一个刚性的一个需求啊，刚性的一个要求啊。然后呢，我们实际上在前年吧，我们也提出来要构建新型电力系统，因为中国呢，我们的现在的煤电的话还是超过了60%。那然后我们下一步的话呢，我们可再生能源装机容量到2050年，我们装机的话要达到90%以上，发电出力的话要达到80%以上。那这样子的话，就说整个的我们的电力结构，实际上就是波动电的这个构成。在整个电力系统里面就跟我们现在的煤电的这个就是跟现在的这个化石能源的这个发电的这个正好倒过来了啊。那这样的话就是说在这样的一个环境当中，我们要解决大规模的储能，刚才李教授说到就是说我们电化学储能就是目前是应用最广的，但是电化学储能呢，它确实就是它也不是一种技术路线解决我们这么大规模的这样一个储能需求是很难去实现的，所以一定是多种技术的这种那个互补，然后呢这个才能够解决这种大规模的。那么还有一个问题呢，储能实际上还有解决一个周期性的问题，就是比如说像我们的水电它是一个季节性的一个波动，但是风电和光伏呢它是一个时段性的这种波动。但是在电力的这个就是整个的这个电力终端的我们需求呢，它又是相对稳定的，我们怎么样子把全年或者是某一个时段性的这种波动性，然后呢去供应一个稳定需求的这样一个市场。那这个储能就是对储能的这个技术就提出了很高的一个要求，也就是说要跨时段的，要长时段的，要长周期，还要大规模，就这个矛盾是比较明显的。我们最近研究发现呢，就是说像中国啊，实际上美国的这个天然气管网比我们中国更发达啊，我们的国土面积实际上差不多的。那么美国的目前的这个整个的地下管廊就是气网的话，是我们中国的大概是2.5倍到3倍吧，这样的一个量啊。那么我们发现呢，就是我们的长输天然气管道和我们的城市燃气的这个管道，它下面的就是我们的这个设计冗余啊，我们的现在的实际的储量和我们的这个设计量之间还有30%到45%左右的这样一个这样一个冗余，也就是它是一个我们可以把它理解成一个大水池子。那么我们现在这个水池呢，只用掉了大概60%到70%。那我们随着以后储能的话，如果电转气，就是像我们闵教授研究的这个 SOEC 这个路线啊，这个我们的这个制氢技术路线发展成熟的话，我们制完之后，我们对基础设施的这个投资的这个建设啊， 那就可以降低，就是通过去评估现在天然气管网的这样的一个技术的可靠性，把我们的这个天上的这个可再生能源或者我们电网里面的这个用不完的这个能源，暂时的把它储备到这个气网里面去。那么气网呢，它有一个特点，它是这个水池子呢，它能够解决一部分周期性的问题。当然也不能说你说几个月或者几个月的时间很难去解决，但是它确实能解决一定周期性的问题，这是一个。那么第二个呢，气网我储到气网之后，我到终端去应用的时候，我应用的这个就是用能的终端的这个方式或者这个技术呢就有变化。我在终端我可以这种就是我们叫这个大容量的大的这种发电装置啊，就是比如说我们用天然气发电啊，或者用掺氢的天然气发电，或者用纯氢的这个去发电，这是可以通过这种大的装机容量去解决的大电厂。那么其实还有一种更好的方式是什么呢？就是说我终端的话，我可以用分布式，就是我们燃料电池的这种技术，或者是刚才杨教授和李教授都提到的我们的这个 EV 的这个技术往家庭里面去供电啊，就是我在低谷的时候储能了之后，实际上我在峰值的时候，我也可以作为家庭或者作为一些小规模用能的这样的一些用户，然后去给它供电。那也就是说，以后的话储到这个气网里面去之后，因为这个气转电的这个路径，您比如说我掺氢的天然气，我可以直接用 SOFC 去发电；如果纯氢的话，我可以用 PEM 的这样的一个路径去发电。也就是说，在终端应用的话，实际上气网到电网的话，它的转化效率比较高。完了之后呢，它的这个技术目前来说，这个也是比较成熟的。然后呢，为我们以后的这种能源的分布式的这种发展的这个趋势，就是提供了一个技术的这个支持啊。那么因为效率高呢，也能够达到一个减碳的一个目的啊。所以我们提出来就是气网和电网的融合啊，可能是未来解决储能的一个技术路径啊。我要补充就这些，谢谢。
Thank you. Well said, Professor Zhao. I think now probably is a good time to release the results of the polling because our speakers have shared their wisdom. So just to go through the questions, actually 62% of the audience got the first question correct. There is actually no freely funded hydrogen in the nature. We have to convert it from the compound. So the second question, actually, over 90% of the folks got it right. And the third question, cannot blame you to underestimate the total number of the cars. I think I can consider both 80 million or 100 million to be correct because apparently Professor Yang said 80 million and Professor Li think that we will have over 100 million EVs in China. But regardless, we're looking at a really exponential growth in the next 6 to 7 years because I think maybe there's a typo. I think it's 2030. We're supposed to see a really large amount of EVs on the road. So and the question 4 is all of the above. And the question 5, I think the answer is according to Professor Zhao's comments, power to gas is extremely important. And as a main storage, a large-scale long-term storage solution, I think hopefully all the audience got some important knowledge today to power our further discussion today. So now I am going to read a few questions that are coming from the audience that asking all the panelists of those questions. So I guess the first one, I would rearrange the order a little bit, is from Rui He. The person is asking, how will international cooperation play a role in this energy transformation? I want to invite Professor Yang to maybe make the comments first.
I think, our event today is a good example. In fact, for the carbon neutrality and also the new technologies, we need to learn each other, and it's really very important because it's quite many new things and also the new business models. So we can see which one will be the keys, and we can. It's very important. I do believe, different country, they have the different advantage or maybe concerns. So there is no any island as you can notice. So for this relative technology, I think we must be more inclusive, and also we cannot only support one country, because without like China and the US, we couldn't achieve the climate goal. It's impossible for the whole world to achieve that. So we must learn and support, cooperate each other. Thank you.
Thank you, Professor Yang. Yeah, I totally agree. As I introduced, we're all citizens of planet Earth. So we breathe the same air, and it's really important for us to share knowledge, particularly concerning how to tackle the climate and energy crisis. I will move towards the next question from Theodore Coney, who's asking about what about the challenge of the waste at the scale as we're scaling the hydrogen or scaling at the batteries? Waste might be low right now, but what about if everything goes at the scale? Perhaps, I think the question is more directed towards, battery manufacturing. How do we deal with the question about, spent batteries and all the waste that could be generated during the manufacturing process?
Okay, I would like to say something about this. So currently, because in battery, lithium, cobalt, nickel, copper are contained in the battery cells. Those are very valuable elements. So the recycling of the battery become a very economic industry. Many companies pay much attention. So, but there are at least three steps. Firstly is the reuse. So after the use of the battery in the car, then we consider to use it for the energy storage. This become a synergetic application. After the reuse, then we open deassemble the batteries, and then try to regenerate the cathode or anode material from the electrode sheet. And the third step is to extract the valuable elements such as lithium, cobalt, nickel, copper by the extraction chemical method. So because of the economic driving force, so last year, 10,000 companies have been registered for recycling in China. Because the lithium cost, the price of lithium cost increased from about 12 times higher compared to 2018. It's very expensive. So, and also some country with the lithium already try to form a so-called LEPAC, So we have the OPEC, so now it's have a LEPAC, try to counter the lithium source. So for that reason, and recycling become very important for the battery. So this is no doubt. And many technologies have been tried to develop, such as automatic checking, automatic deassembly, and automatic extraction of the materials. For the hydrogen, for the fuel cell, already contain very noble metal, platinum. So this is also very important for recycling. No problem. It's not necessarily worry about. So, but the final problem is after all kinds of extraction of the valuable element, what's about the rest of them? So rest of them have also been restricted by the central government. You need not to form the second pollution. This has been already required by the law. So at least in China, and I think in European country also try pretty much touch. As I know, the DOE has some very big project for developing the recycling of the battery. I think most of the developed country and the developing country try hard to do the recycling, reuse, and regeneration of the battery. So no doubt, no problem.
Mm-hmm. Thank you, Professor Lee. Yes, indeed. Actually, in Argonne National Lab, we host one of the major consortium for the battery recycling program of DOE called Resell. And I've seen some very innovative method of, dealing with the battery waste and reduce the carbon footprint to extract the important elements. I also want to say that one of the things I learned interestingly is that the utilization of the cars compared to the airplanes is very low because of the old business model, like everybody drive their own cars. So only 25 or 30% of the cars are being utilized at any time. But on the other hand, the airplanes, they are always being utilized very well, 70 to 80% utilizations. So I really like, what Professor Yang mentioned also. We will need a new business model to think about, how to improve sustainability, reduce waste, and then utilize what we have more efficiently. So I think the discussion is really good. The next question actually will concerning somebody is probably thinking about investment. I have a question from Zoe Zhong, said, is there a clear technology roadmap in both China and the USA for which particular technologies to invest in or to support? And are there still many competing technologies around? Because, we don't know who are going to be the winner. The players on the ground, the mostly established, are the most players establishment. They are like big players in energies, or are there chances for innovative small companies, small firms?
I answer this question or response because I have the experience to set up several startup company. So I think this is clear. Actually, new energy is the most hot, most hot topic for the investment field. Become the number one now. To previously it's internet, So right now it's a new energy. So there are many possibilities. Either invest a very successful big top manufacturer, or you invest a startup company to get more feedback, more high feedback. So, and there are many new companies already registered in the new direction. Big company, because invest a lot on the current available technology. So they try to invest in traditional technology, but new technologies cannot be stopped by their action. So there are a lot of opportunity for startup company. I think both in China and in USA right now, there are many startup company by different way go to stock market like SPAC in USA and also in China. Also, there are this kind of opportunity. I think finally you need to have a really a new product which has a very competitive performance and the cost, so then you will win the fight. So I think it's the list of the direction and the company is on the ground, very clear.
Thank you. I want to invite the professors in the hydrogen field. Are there, players that are innovative small companies or big players? For instance, petroleum. They don't call themselves petroleum company anymore. They all call themselves energy companies. So I would like to hear Professor Zhao or Professor Ming's comments.
Excuse me. Let me make a few comments regard to the hydrogen technology. For hydrogen production by electrolysis, for example, what the technology available right now. I think the main thing is if a startup company or established company can find a way how to design the system so that to produce the hydrogen at the low cost, that could be an approach that not only for big company but also for a startup company. There are many things that can be, the hydrogen storage. That's a very important area. If you have a new technology in that could be potential for a new company or startup company. Usage of the hydrogen, it can be used on a variety. So there are ways that how you dispense hydrogen, for example, the technology, how to dispense, deliver hydrogen, that's another important area that could be developed for commercialization.
Thank you, Ming. I think this is a good point. I think the next question is probably someone who had experience with EV in China. So the person is asking, Sichuan is a major power supply province in China, but this year the power supply has problem. Many electric vehicles have problems, which means that the energy source of the EV probably is not as stable as fuel. What does the panel think of this phenomena?
Okay, I give a quick response. I don't think it's a problem for EV. It's a problem for the whole grid, because this year it's a drought. The hydro power not so powerful. So there are lack of the electricity in Sichuan. It's not only lack for the EVs, but it's really a problem. If you have no electricity, then your EV couldn't work. Then it's really relative. But these things remind us really the system approach. Not only EV can work well. So without a very flexible system, the EV couldn't work well. So that's why I emphasize the smart charging and also the V2Gs. It's and also renewables. You will have a solar PV in your home, and then you can charge your EV, and you can support maybe your workplace to have some electricity. That's also possible. But you want to scale, and also response a little bit to the former question. We need high technologies, but it's not enough. We need the cheap high technologies. If it's not competitive, then like the shale gas, not because shale gas is a good technology, because it's cheap. So, and for the new energy, it's also it's a competition. It's I do believe the business model is as important as the technology itself. Thank you.
Yes, and I totally agree with Professor Yang said. I think it is time for us to all reimagine how the future grid will look like. Yeah, even in California, I drove the electric vehicle in the very, very hot day. We were forbidden to use the supercharging because we have to preserve the energy. And when your EV is low in batteries and you cannot charge the batteries, it's extremely anxious, very, very nervous and anxious situation. So I think while at the moment it's still controllable situation, I think all the technologists and policymakers and investors really have to think about what the future grid will look like, because otherwise the EV growth will not be sustainable. So I think Professor Yang's comments well received, and I thank the person for the very good questions. I think the situation you face is not even in Sichuan, it's common in California as well, and increasingly becoming so in the very hot day in California. That actually is a good segue to the next question by John Potterfield. I think the person asked a very deep question. So let me see if I can ask the question in a proper way. So I think what the John means is that given the concentration of the assets and the population near the coastal line, are there any people or research groups in either US or China, or maybe this is a collaboration opportunities to study how a world policy to reduce, the transfer of those seriously depleted terrestrial waters to oceans, because some places have drought, some places have flood. And I think typically in the very crowded places like Shanghai, New York City, whenever we have flood, and there's $1 trillion worth of asset loss. So the redistribution, I guess, this is a very high level questions. The person has been looking for such a team to work on this type of difficult problems, because obviously for food securities, we need the water for the crops and for agriculture. So I don't know if any professors have this type of high level insights about, we don't have even a climate and energy problem. We have a water problem as well, and they all interconnected together. So yeah, that's a very deep question. So I hope I, crafted it well enough.
Let me address that question. Although I don't know much about, what's really going on, but actually in the US, there's some meeting regard to the availability of water. So there should be information regard to the water at different regions in the US. But in fact, I don't know the detail, but I know that there's some meeting and concern raised regard to the availability of water at certain area, and how you address that issue, especially in the US.
Only add, it's really a big question. It's covered so large issues, but I think I want to add one. The decentralized, approach is very important in the future. It's like the decentralized energy and the decentralized supply of other things. The world is not like the former structure. The structure should be changed. Then it will be more reliance and more safe, maybe.
Yeah, maybe I can add my 2 cents here. I think that hydrogen technology provide a potential possibilities, because as far as I know, the product of hydrogen is water. So we're hoping maybe there is an opportunity for redistribution of the water there. But at the moment, I think we don't have a clear answer to John's question. Clearly, the question is deep, because all the panelists are thinking hard about how to address this question. But clearly, I think, water is probably the next really important topics that both US and China have to think hard about how to, at the same time dealing with drought and flood. I think this is adaptation of both countries of the climate change that we're seeing increasingly more droughts and more flood. So certainly, I think a topic that the two countries can collaborate on in the future. The next question, I think, concerns with the future energy grid that certainly will require 5G communications, or perhaps beyond 5G. How should the utility companies think about their communication network in the future? I think this is probably not exactly in our own circle of work, right? I don't know if any professors can make some comments about communication network for the future grid.
Okay, anyway, we should give some feedback. I think you know, in the energy, we're also talking about the IoT, the Internet of Things. You know, it's because we can enable the digitalization to give a better solution, including not only EVs but also other applications. So I think yes, I think the 5G will be useful, but we must use in a proper way to have value added, not just to use it.
Yes, I agree. Yeah, and Professor Lee mentioned about a lot of the autonomous features of the future EV, because for V2G we will need smart algorithms for, you know, self-parking, self-driving, or self-charging. I took notes. I think all those commands. I think all these features will require, you know, seamless wireless communications. That's quite obvious. So yeah, so we're approaching the end of the webinar. So maybe the last question I could ask is that, you know, clearly that the collaboration between the two countries are, you know, important and beneficial. I would say that especially in terms of the lessons learned, you know, what's working well, what's not working well. I wonder if, you know, the professors here have any plans to, you know, how would I say, continue such a dialogue, and perhaps writing a perspective paper together that emphasize the importance of lessons learned, both in the battery energy storage industry as well as the hydrogen deployment. I want to hear about your comments about the collaborative features that we should encourage both institutions to establish. So follow-up actions.
Actually, in the clean energy and also battery field, they are a national level collaboration project, you know, between USA and China. I think this is a very few national project, international project between China and USA. This is very good news, and already continue nearly 10 years between two sides, from DOE and MOST to do this. I think that this project just finished the last term evaluation, and then could go to the next new one. So that's then, yeah, as you mentioned, we need to write a perspective article to mention the benefit for both sides. It's how to get a win-win solution to. Yes, actually, the production chain has been developed very well in China already, and also there are a lot of collaboration between China's research team and the US team. Many. I think the most active collaboration is between China and the USA, between scientists and also between engineers. And there are many published papers mention this. So we should mention and make a summary and make a count how many collaboration already performed for certain years. Maybe it's very important to write clear. So it's become a decreased tendency or increased tendency, and the beneficial. And also for long term, yes, the climate and energy I think is very important, not only for each country, for the world. So it's really the role and the duty for each country to do very well.
Thank you, Professor Lee. Yeah, I totally agree, and I certainly hope there will be follow-up actions after today's, you know, really insightful and productive webinar. I hate to say that we're at the end of the time, so really thank our panelists today for this very engaging conversation, you know, and I think thank all the audience for joining us today on Zoom. We will have another event on November 5th at 7:30 Central Time. And it's actually November 6th in China, morning time, 8:30 morning time. The topic is on climate-resistant ecosystems as solution to climate change. So I really hope that all of you have either have a good day or have a good evening. And thank you all for joining today's event. See you next time.